based on the most important Q for you. So how this translates into probability reasoning is pretty simple. Basically, again, this works for decision theory because the question is, what do you want and what matters to you? Which are basically the same question in a decision theory context. In the question now of, let's say, like, which of these two outcomes is more likely? The question is, the analogous deeper question of like what matters to you is, so you know a lot of stuff about A and B. What is the most important information that will allow me to answer that question? And so the paradigm that Gigerenzer uses throughout his study is he takes Germans and Americans, or like computer people, and makes them and gives them varying amounts of information about cities in America and Germany. And so these will be cities like Hamburg and Frankfurt, or like Dusseldorf and nameless German town, and like, pairs a lot of them in terms of like how notable they are and how unnotable they are, and does the same for American cities. And asks them, okay, so which of these is more, which is larger? And what he does in the computer simulations is that he gives his simulated subjects either a lot of information about these cities or not a lot of information about these cities. And so for some of them, so now in terms of like, okay, so we're trying to figure out which has the larger population. Let's see, like, what tools do you think would be helpful in determining what is, like, what would you use to answer this question? Like, what information would you like to have to know between cities A and B, which would have a larger population? What features would you like to know about the cities? Well, duh, but no. What?
Population density?
All right, so we've got density.
Political status, like is it a capital? Is it a regional capital?
Anything else?
Housing development?
Like what level of housing?
Like apartments versus cottages?
Yeah, and like how many new developments?
The amount of light pollution.
If it's famous, and if so, what for?
Other ones that Gigerenzer has mentioned that are commonly used, like, does it have a major sports team? But this famous one is the most important, and the one that people don't always think of answering because it's just kind of so obvious to them. Have I heard of the city before? So the question of, have you heard of Dusseldorf versus Frankfurt? Or have you heard of nameless Germantown versus Frankfurt? And chances are, if you've heard of it versus if haven't heard of it, that's bigger. And so,
if we bring Africa and China into the question, the heuristic is wrong 100% of the time.
it's really sad. Or Africa and China.
Like of the like top 50 cities in the world, I have not heard of like.
Okay, well, that is cool to know, and probably why Gigerenzer is specifically talking about Germany and the United States. So the process is very much the same. We've got all this information, and so for his simulated subjects, they either have like a lot of this stuff or very little, and they have differing amounts of information about each city. And so what some of the subjects do is they take all of this information and like they have perfect information, and they organize it in terms of like what is most likely to give me a correct answer on this question. It's that same sorting procedure of what are my priorities, and then they assign the weights to them and say, well, this is really important, so I'm going to assign a lot of weight to it. This is not so important. And then they check them off down the list. So like, well, this has this, and this has this, and this is more likely to be, this makes A more likely, this makes B more likely, this makes A more likely. And they do another linear model, and they get their answer. And they tend to be correct. Other simulated subjects are given less information or told to use the take the best heuristic. And so they organize things, and it turns out when they use name recognition as the top piece of information in this queue, they're quite correct. And they perform on par with linear modeling. Another case of linear modeling and taking the best heuristic working just as well is trying to one thing grad student admissions officers have to do is pick. It's like figure out how well an incoming student will perform during their first year, and in the same way that your SAT is a very loose predictor of your first year GPA, that's what the GRE is for your first year GPA as a grad student. And then also other things they take into account are your major GPA, your overall GPA, professor recommendations. They've got all this information. And so it falls to the admissions officers to figure out how to sort all of it and how to make sense of it. And so what admissions officers tend to do is that they look over all this information and they say, and at giant schools, even at giant schools, this isn't really a problem because grad departments tend to be small enough that they're looking at each individual application and not just using massive cutoffs like they do for undergrad schools. So that's why these other psychologists chose graduate school specifically. So they look at all this information and they think, okay, well, this is important and that's important too. And they produce what psychologists call a gut judgment. And this gut judgment has a 0.2 correlation with their gut judgment of what these people's GPAs will be has about a 0.2 correlation with what it turns out to be. So when you then develop a linear model that says, I think maybe you assign the most weight to a GRE and then major GPA and then professor recommendations are at the bottom, you get a pretty substantial improvement. You get to about 0.4. And considering all the variables involved in trying to predict these things, 0.4 is not bad. It's certainly a lot better than 0.2. So the moral for this story is that maybe grad student admissions officers should be using linear models in making their decisions. But what is more interesting here than that linear models work better than gut judgments is that when you fuck with a linear model, it also still works. So the thing I gave you was, model I gave you was like the completely normatively rational model, where you take the most important priorities and you give them the most weight. When you take all the priorities and you give them equal weight, when you take all the priorities and you give the least important one the most weight, when you do any kind of random manipulations to them that you want, they only perform slightly worse than the normatively rational linear model. Linear models work better because they're consistent. Gut judgments don't work because how you're feeling that day will affect how you view a personal recommendation and and like the writing style of the recommendation will impact how much you're likely to agree with it, and there's a whole bunch of variables. Linear models cut out a lot of those variables and leave just a few. And the take the best heuristic winds up performing just as well as the normatively rational linear model. Because again, it's a very simple decision rule. You're just taking the most important priority and saying, I'm going to go with that. And that works. Whether we do that, I'll get to that in a bit. But that's a really powerful finding there that I think is worth noting. Why that happens, I think it's a statistical artifact of just like you get a ceiling effect of you can't predict things that well, and if the first weight is that important, then the other weights just aren't going to be as important. And so if you're only using the first weight, like your line might, like the normatively rational, like your line might be like this, and the normatively, and the take the best one might be like this because the other terms impact the slope of the line, but it's the first term that's most important. And so, voila, take the best is a beautiful thing. But do we actually work that way? There's a bit of evidence that we do. So Giga Renzer took actual Americans and Germans and asked them whether San Antonio or San Diego is larger. So of you guys, who thinks San Antonio is larger than San Diego? So SA and SA. San Antonio. San Diego. And again, one of you has ceased to exist. I don't actually know which is larger. Do I? Because the paper didn't say. Do you?
Probably within a third of each other.
Yeah, they're really
Also, does one of them have more name recognition than the other?
I don't think so.
Sorry.
Well, Americans get it right about 62% of the times. Germans get it right 100% of the time.
On our city?
Yeah, well, on these cities, yeah. We have a really hard time discerning, because we have a lot of exposure to both these names, we have a hard time discerning what's really name recognition for other countries. But information gets filtered out somehow, and for some reason one of these cities is far more recognizable